The chapter we are going to study today is electrochemistry. Electrochemistry is concerned with a wide range of significant processes, many of which are dependent on the exchange of electrons from one chemical to another. Electrochemical processes include redox reaction, where the energy released during spontaneous reactions is converted into electricity, or in which the electricity is used to induce a non-spontaneous reaction. Redox reaction involves the transfer of electron between two or more substances. Electrochemistry deals with the energy resources that are highly efficient, such as batteries and fuel cells. The chemistry of these devices is discussed here. So redox reaction is basically the transfer of electron between two or more substances. So what is oxidation reduction concept? So we already know that oxidation is basically the loss of electron and the gain of oxygen plus the and when we talk about the reduction, so reduction is basically the gain of electrons and the gain of hydrogen. And here we have the example, that is example 2.1. So when a piece of zinc is dipped in aqueous solution of CuSO4, it is observed that a dark brown layer of copper begins to form at the zinc surface. At the same time, the blue color of the solution is discharged. If we analyze the solution, we find that zinc ions are present in the solution. Change can be described as follows. Zinc plus Cu2 plus gives us zinc 2 plus copper. The reaction can be described in terms of two half reactions. Zinc gives us Zn2 plus 2E negative, and copper plus 2E negative gives us Cu. So in the first one, when there is loss of electron, the oxidation is happening. In the second reaction, the reduction is happening. So basically it's these two processes are simultaneously happening, and they are called the oxidation reduction reaction. A reaction in which substance loses an electron is oxidation. The reaction in which a substance gains electron is a reduction reaction. So what is oxidation number? The oxidation number or oxidation state is defined as the apparent charge, positive or negative, which an element would have in a compound. Oxidation reduction in terms of change in oxidation number. We have already defined oxidation and reduction in terms of transfer of one or more electrons. We can also define oxidation and reduction in terms of change in oxidation number. An increase in oxidation number is called oxidation, and decrease in oxidation number is called reduction. For example, 2Na plus Cl2 gives us 2NaCl. Assign oxidation numbers to all atoms. So 2Na plus Cl2 gives us 2NaCl. Notice that the oxidation number of sodium is 0 because it is in elemental form. In this reaction, the oxidation number of sodium changes from 0 to +1 when it loses one electron, which is the oxidation. So Na gives us Na positive plus 2E negative. On the other hand, each chlorine atom in the Cl2 molecule changes oxidation number from 0 to -1, gains 1 electron, so it is reduction. Oxidation is increase in oxidation state, and reduction is the decrease in oxidation state. So in the first one, there is the increase in oxidation state. So sodium reaction is the oxidation reaction, and chlorine reaction is the reduction reaction. Identify the elements undergoing oxidation or reduction in terms of change. So CH4 plus 2O2 gives us CO2 plus 2H2O. So CH4 plus 2O2 gives us CO2 plus 2H2O. The carbon, its oxidation number changes from -4 to +4, whereas oxygen changes the oxidation number from 0 to -2. This means carbon undergoes an increase in oxidation number. On the other hand, oxygen changes oxidation number from 0 to 2. In O2 to -2, in H2O and CO2. Each oxygen atom gains 2 electrons, and therefore it is reduced. Carbon is oxidized because there has been an increase in oxidation number, and oxygen is reduced because there has been decrease in oxidation number. So what is disproportionation reaction? In some redox reaction, the same element is oxidized and reduced simultaneously. Such reactions are called self-oxidation reduction reactions. Like we have 2H2O2 gives us 2H2O, and for the oxidation, H2O2 gives us O2. Balancing of equations. Redox method and ion electron method. Redox method is oxidation number method, and it is based on the principle that any redox reaction, the total number of electrons lost by one element must be equal to the total number of electrons gained by another element. Phosphorus plus HNO3 plus water gives us H3PO4 plus NO. Okay, now in this reaction the phosphorus goes from 0 to plus 5, so it is oxidizing, and nitrogen is going from plus 5 to plus 2, so it is reducing itself. So we can balance this equation as well, and the last that balance equation is 3 phosphorus plus 5 HNO3 plus 2 H2O gives us 3 H3PO3 plus 5 NO. Construction of redox equations. There are two half reactions in any given oxidation induction reaction: the oxidation half reaction, induction half reaction. The oxidation induction reaction is the sum of the two half reactions. We can balance the half reaction by the ion electron method. Equalize the number of electrons lost and gained in two half reactions and combine them. The rest of the equation is balanced by the inspection method. These steps involved in this method can be understood by considering the following example. Cr2O7 gives us Cr3 positive, H2SO3 gives us HSO4 negative. Cr2O7 gives us 2Cr3 plus, Cr2O7 2 minus gives us 2Cr3 plus 7 H2O. So when we add 14 hydrogens, so it will become 2Cr3 plus 7 H2O. So this is how we are going to balance the chemical equations. By adding the electrons, hydrogens, and by balancing the number of the oxidation states, so we can balance these half cell equations. Okay, the important topic here is oxidizing and reducing agents. An oxidizing agent is a substance that accepts electron and causes oxidation, therefore its oxidation state decreases. Reducing agent substance causes reduction through the loss of electrons, its oxidation increases. This means an oxidizing agent is a substance that causes oxidation of another substance. On the other hand, reducing agent is a substance that causes another substance to reduce. An oxidizing agent contains an element that is being reduced. The reducing agent contains an element that is being oxidized. So 3P0 plus 5 HNO3 plus 2 H2O gives us 3 H3PO4 plus 5 NO. P is undergoing oxidation, so it is a reducing agent, whereas N present in HNO3 is undergoing reduction. HNO3 is an oxidizing agent. MnO2 plus 4HCl gives us MnCl2 plus water plus Cl2. Okay. So the substance that oxidizes itself and reduces others. Okay, oxidizing agent is an element that is being reduced and it oxidizes others. So it is oxidizing agent, and reducing agent is that which is being oxidized by losing electrons and reduced others. Now we have electrode potential, electrochemical series. The galvanic cell, which is a Daniell cell. When a zinc rod is dipped into copper, zinc atoms are oxidized to zinc and copper are reduced to copper metal. So zinc plus copper gives us Zn2 plus copper. So this is basically the setup of a simple galvanic cell. Here we have zinc Zn4 solution and CuSO4 solution. So they have both electrodes on the zinc anode and copper cathode, and they both are connected with the voltmeter, and in the middle we have the salt bridge that maintains the salt concentration of the solution, and is filled with some electrolytes such as KCl, KNO3, Na2SO4. So galvanic cell, when a zinc rod is dipped into copper sulfate solution, zinc atoms are oxidized to zinc ions and copper are reduced to copper metal, which deposits on the zinc rod. The following reaction occurs. Okay, In this reaction, electrons flow directly from zinc to copper. However, the electron transfer from the zinc rod to the copper in solution could be directed through an external circuit. The spontaneous redox reaction could be used to generate an electric current. But when a zinc rod dipped in the zinc sulfate solution is connected by a copper wire to a copper rod dipped in the copper 3 sulfate solution in a separate container, no current flows through the external circuit. However, when the two solutions are connected with a tube filled with a solution of electrolytes such as KCl, KNO3, Na2SO4, the current flows through the external circuit. The salt bridge allows the movement of ions from one solution to another without mixing. The two solution maintains electrical neutrality within the internal circuit, and the ions prevent the buildup of charge in their half cell, which would otherwise stop the reaction flow of electricity. Half cell in which oxidation occurs is called oxidation half reaction. The other half cell in which reduction occurs is a reduction half reaction. The reaction taking place in the oxidation half is called oxidation half reaction, and the reaction taking place in reduction half is a reduction half reaction. Half cell is a reduction half reaction. So the electrode at which the oxidation occurs is anode, and the electrode at which the reduction is occurring is a cathode. So zinc has the greatest tendency to lose electrons, so therefore the zinc electrode acquires a negative charge relative to copper electrode. The electrons flow from the zinc electrode to the external circuit to copper electrode. The following half cell reactions are occurring. Zinc gives us Zn2 plus 2e negative, and copper 2 plus 2e negative gives us copper. So overall reaction is Zn plus Cu2 plus gives us Zn2 plus copper. So that's all for today's lesson. Thanks for listening.